Hello everyone, my name is Sergi and I'm going to show you some tricks about bouncing objects. In the video tutorials we have seen that we can bounce a ball against vertical walls and also against horizontal walls. Okay, but what do these conditionals really mean? In fact, these are the equations of the vertical and horizontal lines that will make our ball bounce. What we are saying to the computer is, find me a point from this line that has the same height as my ball and evaluate its distance to the ball. But what happens when we have a diagonal line? We don't have neither its equation nor any points in the middle. Remember that despite we see a line in the canvas, we only know the two edges of this line. Okay, now imagine that the ball touches the line. There's only one contact point between them. This is the nearest to the center of our ball. But this point is also the intersection of our wall and the line that comes from the center of the circle. Okay, I've wrote here the equations of the line that goes from point A to B. M is the slope, which is the increment in y divided by the increment in x. What is useful here is that it is perpendicular to our wall, so we know its slope is the inverted and negative of the slope from before, right here. As the unknown point is part of the two equations, we can find it by solving the system here. I have isolated the y in both equations. Now we have each component of the point that is the nearest to the center of our ball. So this way we can say to the computer, hey, measure the distance between this point that is the nearest to the center and compare it to the radius of the ball, so make it bounce or not. But we have to be careful because this point that we find belongs to the line, and the lines are infinite from both sides. So what we don't want is the ball to bounce against an invisible line that is not part of our wall here. The way to accomplish that is to say, hey, if the point I found is bigger or smaller than A or B, I choose A or B instead of this point. Okay, so let's go to the practice. I've defined a function that has 5 arguments. The first one is the first point of our line, the second one is the last point of this line, the third one is the center of our ball, the fourth is the radius of our ball, and the last one is the velocity of the ball. I know there are so many arguments, but don't worry, don't panic. Okay, this part I will explain you later. And here we have the equations that we have found. M is the slope. We know B1, A1, B0, A0. We know this because we know the points that are used to draw our line. Okay, and we have found X and we have found Y. Okay, now here is the part where I say if my XY point gets out of range, give me A or B instead. Okay. Now we have a function that detects the nearest point to our ball. Let's see it in action. Okay, I have drawn some extra lines, but you can see the blue line is marks the nearest point to the center. Look, here is the 90 degrees, and then the ball bounces. So we still haven't programmed it yet, but you can see that the blue line always points to the nearest point to the ball. Okay, now in order to determine which is the angle of the ball after bouncing, we need to know some things about vectors. This is a vector. Vectors have modules which is the length of this line, and have the x component and the y component and an angle. Okay, so we will need to remember some equations from our from from school. The first one is that the module is as described in the video tutorial, is the first component squared plus the second component squared and the square root of all this. Okay, and also we can find the angle of a vector knowing its components by this equation are tangent of the y component divided by the x component. And we can also know the vector components if we know the module and the angle by trigonometric equations. Okay, this is a representation of what will happen when the ball hits our line. Okay, the ball comes, for example, from here with a velocity with this angle, bell angle, okay, and gets out with another angle, we don't know it. And this line here is the line that goes from the center of the ball to the nearest point that we have found. Okay, and we can see that this angle here is the same as this other angle here. Okay, so this line is actually it's like a kind of a mirror. Okay, so if we say that the blue angle is the difference between the mid angle and this other angle, we take this part out from this one, we can say the new velocity angle is the velocity angle from before plus 2 times this blue angle. Okay, so this is the equation, and the velocity angle is the velocity angle before plus 2 times this difference. And the only thing that we need to do now is, with the new angle of the velocity, just calculate again the components of velocity. So this will be the components of the new velocity of the ball. So if we go to Code Sculptor again, we define the midline angle, velocity angle, velocity module, and the distance between the center of the ball and the new point that we have found. We can now start the if statements. Okay, we say if the distance between the center of the ball and the new point we found from the line is equals or lower than the ball radius, then I want the ball to rebound. So just calculate the new angle of the velocity and give me the components of the velocity. Okay. Okay, let's start the example from before. This is the direction of the velocity. The ball starts looking for the nearest point. Here it is. And the ball bounces and the angle changes correctly. Okay, one more time, let's look that this angle here right now is the same one that this other angle here. So it is working. Okay, and we can bounce against an edge. Okay, it works, and we can bounce a little higher. Let's see. Okay, it seems it works properly. Okay, before showing you another example, I want to point out the part that I said I would explain later. Okay, here we have some if statements. These are made because if we have a vertical or an horizontal wall, we can't calculate the slope of the line because the denominator gets 0 and we may have an error. So this solves the problem. Okay, let's see another example. Okay, this is another example. Here I have defined some points, point 1, 2, 3, 4, 5 from one polygon, and they will be from one polygon, and point Q1, Q2, and Q3 from another polygon. Okay, I have the function defined here, and inside the canvas I set the velocity to change the position as in the Pong mini project, and then I have defined the polygon that will close my ball inside. Okay, and I defined the bounce function here for each side of the polygon and for the ball number one. And then I did the same with another polygon and another ball, which are in red color. Okay, let's start it here. And you can see that it seems to work properly. Okay, good. Let's see another example. I did a variant of this function so that the ball bounces against a circular wall. Here you have it. The ball bounces with inside a circle or outside from it. Okay, it works good. Okay, so I will let you the codes and just try to understand everything well, and you can use it in your programs if you want. Okay, see you.